Okay. So same as it's regular chain rule, but now we're putting in ln's and e's. So this is your f or your outside. This is your inside. So if I were to just review chain rule real quick, remember the derivative of f of g of x. Take the derivative of the outside, you leave the inside alone. Then you multiply by the derivative of the inside. So the derivative of ln of something is 1 over, and then you leave the something alone. So like the derivative of ln of x is 1 over x. So the derivative of ln of blah is 1 over blah. And then you multiply by the derivative of the blah. And then one of your simplifying rules is going to be put in one fraction, one top, and one bottom. So this will just become, remember this is really just like 6x over 1. So if you go straight across, that's 6x over 3x squared. And if I'm on the gateway or a free response, I'm stopping there. Because I'm a slave here, I might screw up. On a multiple choice, they would probably rewrite that as 2 over x. Just shame people now. Yeah. So what's the derivative of ln of x? 1 over x. So the derivative of ln of 3x squared is 1 over 3x squared. Or the derivative of ln of cos would be 1 over cos. It's like the derivative of ln of chunk is 1 over the chunk. And then we're multiplying by the derivative of the chunk. Does that help? Other questions on 1 right there? So it's real similar. Try that one. So again, this is like ln of something. The derivative of ln of something is 1 over that thing. So that's like me taking the derivative of the f part. And then the g part, so I multiply by 12x to the 4th. And again, you're welcome to stop there on a multiple choice. What? Oh, yeah. Sorry, 15x to the 4th. And then multiply straight across. And you don't have to do this, but you get 15x to the 4th. No, I'm sorry, you do have to do this part. Over 3x to the 5th. You can stop right there. On a multiple choice, they'd probably put 5 over x. Alright?
Yeah.
Wait, let me go back. I don't want to go that far yet. Let's say number 2.5 here. Y equals e to the cos of x. So, what's the derivative of e to the blah? E to the blah. And then you multiply by the derivative of the blah. So it's like e is your outside. Cos is your inside. So the derivative of e is just e. You leave the inside alone. And then you multiply by the derivative of the inside. So that would be your answer for number 2.5. Are you guys looking serious?
No.
Other questions? I don't care. I'm just going to tell you this. Yeah, sure. If you want. I mean, there's no difference, right? So I think Matthew's going ahead to like, so let's do 2.75 here. He's like, okay, what if there's like two chain rules? So let's say it was like e to the um, okay, yeah, sine of 2.75x. So now there's an outside, a middle, and an inside, right? So what's your like f? What's your main outside function? E. What's your middle or your g? Sine, and then your inside or your h is 2.75x. So you take the derivative of e. The derivative, so e is your big guy. So the derivative of e is just e. Leave everything else alone. And we move on to the middle. So what's the derivative? Well, what is the middle first? Sine. So what's the derivative of sine? Cos, and we leave the 2.75x alone. And then we move to the inside. So we're multiplying by 2.7. That'd be your answer. So the kind of nice thing with these is there's not really much to do. You have one step, sometimes two to like simplify and clean it up a little bit. Question on that one? So like what Matthew was saying on the last one is if you want to think about it like e is the big, cos is the middle, and then like x is the little guy, you would multiply by the derivative of x out here, which is just times 1. It's not really necessary. So if your little guy's x, you don't really have to worry about it. But you can if you want to put that times 1 there. It's not wrong. Is that okay? Yeah, so it looks a little rougher though. Alright. So, what's the big guy? Natural log. The middle is this chunk. And then you got like its own little chain rule in here. It's alright. So what's the derivative of ln of block? 1 over block. Make sure you realize that plus 4 is like down here. It's not like up with the 3x. Times. So this is done now. I've already like taken care of that derivative. Now I just move on to the e to the 3x plus 5. So for this portion, you got a chain rule here, and then this plus 4 is just going to kind of go away, right? Derivative of positive 4 is 0. So, what? I'm going to take the derivative of all of this. Yeah. It's kind of like this is the middle, and then within the middle, there's like a big and a little. But that makes it sound way harder than it actually is. I think. There's no always like that, unfortunately. So I've done the derivative of f, right? Like the outside. So if I just gave you e to the 3x to the 5th plus 4 and said take the derivative, like that's what we're doing right now. Just take the derivative of this. So with this, what's the derivative of e to the 3x to the 5th? Times 15x to the 4th. Because that's its own chain rule piece, right? Then I gotta take the derivative of this plus 4 out here, but what's the derivative of plus 4? It's just 0. So that's my answer. I just gotta write it so it's on like one top and one bottom. Like that's over 1. And I'm just gonna go e to the 3x to the 5th times 15x to the 4th over e to the 3x to the 5th plus 4. Can I cancel those e to the 3x plus? Can I cancel the e to the 3x to the 5th? Nah. That would be like if you tried to say 5 times 2 and 5 plus 8, and I could cancel the 5's. It's not okay. Question on that one? Yeah. Yep. So let's do that one. Let's say it was y equals the natural log of 4e. So the 3x to the fifth is what you're saying? Yeah, so this one won't go away, right? Okay. So you guys, I don't know if you picked up on that, or I'm not sure I've done a great job of kind of mentioning this part, but if you have a constant in front of, let's say it's like 4e to the x, that 4 is just going to drop straight down and just like hang out there. But I can show you why. If I did product rule here, think about like 4 as your first chunk and e to the x as your second chunk. So like second thing times the derivative of the first thing, but the derivative of the first part is 0, right? Plus the first thing times the derivative of the second thing. So that goes away, and we end up with just like that 4 just kind of drops down. If I had like y equals 4 cos of x, the 4 just drops. The derivative of cos is negative, so it'll be like a negative in front of it, but the constant in front of an e or natural log or trig function just stays. So if I were doing this problem here, natural log of a chunk, the derivative of that is 1 over the chunk times the derivative of that chunk. So the derivative of 4e to the 3x to the fifth, well, the 4 is just going to drop. Your big guy now is the e. What happens to the 3x to the fifth? It stays. And then you multiply by what? 15x to the fourth. And then I could like put it together and stuff. And actually now, I'd have like 60e to the 3x to the fifth times 15x to the fourth. And now we can get some stuff that cancels. 4 times 15. Oh, and then I put the 15 again just for like S's and G's. I was so excited about canceling. I lost all focus. So you could leave it there. But now in this case, I could wipe those. And 60 over 4 is 15, so I could end up with just this. Does that answer your question, Elena? Other questions there? Try that. How about the video? Like half of you look out the window. I think he was floating on it. That one. Guys, do it. Sorry, wait. Yeah, so this is very nice.
Times that by.
Shut up.
Times that by.
Okay. So there's your F, your G, your H, your outside, your middle, your inside. Sorry, wait a second. Are people still working? So the derivative of the outside, derivative of ln is 1 over the chunk that's being ln'd. Times. And I left that inside alone, right? I left that stuff alone. Then I go to the g. So what's the derivative of the g? 1 over the stuff that's being ln. I leave the stuff that's being ln alone. Times the derivative of h times 8x. Like that's your answer? You've got to clean it up. But questions on that? I got to that? Alright. So then you would like put that over 1. You'd say that's 8x over ln of 4x squared times 4x squared. Again, you would not have to do this extra step, but on a multiple choice, you would have to be able to say that it's the same as that. Should wait. You can wait. Can I answer a question while you wait? You just want some processing time. You okay? Evan, you good? Okay. Caleb, you're good? Okay. Can I erase? You guys see that? What? Alright, I can't hear you.
Like, do you ever need to like use this for like equations? Because this seems like a
You mean like in a real world situation?
yeah.
Problem with asking me what happened in the real world is I never really worked in the real world. I've been at school for 40 years, you know. People that I talk to that use calculus, actually, I mean, I'll be honest with you, they tell me like the most important part is like learning how to think in calculus, not necessarily like do computations, because there are calculators that do the computations for you. But your real world is a test of this next week, so there's also that. I don't know. I can't really answer that. Anybody? I'm sorry. I understand you were like, what's the point of this in your life? But just sort of throw it out there. I mean, if you were like modeling some crazy data, maybe this is the best situation that fits it, and then you want to know like the rate at which it's increasing, and so you take the derivative. I mean, I can see that. Do what?
Probably do stuff like that all the time.
Yeah, to do that X. It's an export at that time.
Okay, so that's your outside or your F. That's your middle. And that's your little. So we take the derivative of the outside. So what's the derivative of E? E. And then we leave the G and the H alone. Then I move on to the G, which is E. What's the derivative of E? E. Leave the H alone. Then we move on to the H, and we take the derivative of the H. 12x to the thing. I cannot. Can you? I got lost track of what you're saying. Yeah, we're just gonna stop here. You wanna write it? You wanna show it?
I'm pretty sure this works out, but isn't it like e to the 3x to the 4th plus e to the 3x to the 4th? Does that also work?
This would be, I know what you're trying to do. This would be e to the 3x to the 4th times e to the 3x to the 4th. Because if you added the exponents, it came from a multiplication. So it doesn't quite.
I added.
Hey, Mr. Good. Yeah, can you give me like 10 minutes? Or do you want right now? Right now's fine. Okay. Okay. Alright, thanks. Joseph, after we finish up these notes, Mr. Gill wants to go.
I removed the extra E.
Yeah, I know what you're saying. But that doesn't quite work because what you just wrote is actually e to the 3x to the 4 times e to the 3x to the 8. Oh, yeah. Oh, yeah, that is, yeah. You're right. I was like, no, and then I wrote the same thing. Yeah. You do not, I'm not even sure it's simpler. It's just like a different way to write it. Try that. Can you see that? So I think it's helpful if you, instead of thinking of like e to the x even, like if you just say what's the derivative of e is e, what's the derivative of that line is 1 over. I think that's kind of a more helpful way to phrase it. Yeah. No, but it is part of the exponent. So I think it's
It is most definitely two.
okay. You good?
Wait.
Oh, you're good. I didn't mean to rush you.
Alright, so it's situation times e to the L1, e 2x3 plus 5.
Okay. So this is your F. And like basically this is your G and this is your H. Because is that plus 5 really going to do? I mean, it does have to be written the first time. So it's like part of the F. It doesn't really affect when you take the derivative. I think it's like more confusing in this situation to think of F and G and H. And just it's easier just to go big, middle, little. Let's just go through. So this is your big guy, obviously, right? So what's the derivative of E? It's E. And then you leave everything else alone. And this is the only place that plus 5 comes in. Oh, no, it's not. No. Alright. Now move on to the ln. And that's technically this whole chunk. But what's the derivative of ln? 1 over, and you leave this alone. And then I'm taking the derivative of the plus 5 also, but what happens to that? It's just gone.
It's not the natural one.
It is not. But if I gave you y equals ln of 2x to the third plus 5, instead take the derivative. 1 over 2x to the third times 6x squared, and then plus 0. So that's all I'm doing here. And then plus 0. So if you think about this as like a whole thing, its own like separate problem, and then like put it back almost. Like, why is there a parentheses in the original problem? So ln 2x to the third plus 5 means this. If they wanted the entire thing to be ln, they'd have had it written in like this. Is that part of the issue with
Yeah.
how we did it?
Yeah, is that maybe put +5 on the bottom?
So that's what Matthew asked. That's why I put those parentheses there. That's what I was trying to
Oh yeah, no, I got it.
help with.
What?
Even the LN was used.
ln of e to the something is just the power.
What? Noise.
Yeah, it is. Yeah, it is.
Like ln of e to the 8th is 8.
What?
If you had that,
What?
it'd be 8, but it's not to a power like that. It's so do we want to try it again? Okay. Like, does it make sense if I put those parentheses there? Does it make sense?
Yeah.
Okay. Do you want me to go through what it would be if it was like the whole thing?
No, it's just a +5. Yeah.
Oh, okay. Okay. So I did go back and put like there's a couple product rule, quotient rule, old chain rule, like the basic. I think put me trading on it, I should have, but there's a little bit of review in here on derivatives. Again, I'm not collecting this, I'm not grading it, it's on you, but I very strongly recommend you do check every